Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Keto-enol tautomerism and stabilization through intramolecular hydrogen bonding and conjugation in beta-decarbonyl compounds. Moving on to the next step. Identify the compound. All four structures are tautomers of acetylestone, 2,4-pentanedione, CH3-COCH2-COCH3. Moving on to the next step. A. Deketo form CH3C is equal to O, CH2C is equal to O, CH3. No conjugation between the two carbonyl groups. No intramolecular hydrogen bonding. Least stabilized among the tautomers shown. B. Enol at C1, terminal vinyl enol, is equal to CH2 and CH2 is equal to C, of CH2C is equal to O, CH3. The enol double bond is not conjugated with the remaining ketone carbonyl. There is a CH2 spacer breaking conjugation. No intramolecular H bond possible in a favorable 6-membered ring. C. Enol at C4, internal enol CH3C, of, is equal to CHC, is equal to O, CH3. Here the hydroxyl enol is on C4 giving the structure CH3C, of, is equal to CHO, CH3. The C is equal to C double bond is conjugated with the C is equal to O group, forming a cross-conjugated or extended pi system, OC is equal to CC is equal to O. Additionally, this arrangement allows formation of a stable 6-membered intramolecular hydrogen bond between the O and the carbonyl oxygen, OH. O is equal to C, closing a 6-membered Chelte ring. This combination of conjugation and intramolecular H bonding provides maximum stabilization. D. Dienol form CH2 is equal to C, of CH is equal to C, of CH3. Both carbonyls are enolized. While there is extended conjugation, this form lacks a free carbonyl to accept an intramolecular hydrogen bond in the same effective 6-membered ring manner, and the terminal is equal to CH2 reduces stabilization relative to C. This tautomer is less stable than C. And for the final step, why C is most stable? Structure C has I, conjugation of C is equal to C with C is equal to O, vinyl ketone type extended pi system, 2, a strong intramolecular hydrogen bond forming a 6-membered ring, Chelte ring, CC, of, is equal to CHC is equal to O with H bridging O to O, and 3, resonance stabilization of the enol. This is the classic stabilized enol form of beta-diketones, well known to predominate, greater than 80%, in acetylestone. Therefore, the correct answer is C. Therefore, the correct answer is option C.